You're driving at night, headlights on. The world beyond your windshield is mostly black, but then something strange happens. The road starts talking to you. Thin white and yellow lines begin to glow, not like light bulbs, not like neon, but bright enough to guide you, clear enough to trust. And here's the question: why do road lines glow at night even though they don't have electricity? Let's break it down. First, understand this. Road lines don't actually glow. They don't produce light. What they do is reflect it, but not the way normal paint reflects light. If you shine a flashlight at a white wall, the light scatters in all directions. That's called diffuse reflection. But road markings do something different. They send light back toward the source, back to your headlights, back to your eyes. And that's called retroreflection. So how does that work? The secret is inside the paint. Modern road markings are filled with millions of microscopic glass beads, tiny spheres smaller than a grain of sand. When your headlights hit those beads, something fascinating happens. Light enters the glass bead, it bends, it hits the back of the bead, and then it reflects back almost exactly toward where it came from, which means straight back to your car. And that's why the lines appear to glow. They're sending your own light back to you. Now here's what makes this even smarter. This technology became critical as cars became faster and highways expanded. In the early 20th century, night driving was dangerous, visibility was poor, headlights were weak. Engineers began experimenting with reflective road markings in the 1930s. In places like the United States and parts of United Kingdom, highway safety research led to the widespread adoption of glass bead reflective paint. What this really means is simple. As cars improved, the road had to improve too. But paint alone isn't the whole story. Sometimes you'll see raised reflective markers on the road, small plastic or ceramic bumps embedded into the asphalt. In the U.S., they're often called Botts dots, named after Elbert Dysart Botts, the engineer who helped popularize them. Inside many of these markers are retroreflective prisms. Instead of glass beads, they use tiny corner cube reflectors, like miniature versions of the reflectors on bicycles. They're brighter, more durable, especially in heavy rain, and they serve the same purpose: send light back to the driver. Now let's talk about rain. You may have noticed something. During heavy rain, road lines can become harder to see because water covers the glass beads, and when that happens, the light bends differently as it enters the bead. The reflection becomes weaker. That's why modern road engineering includes wet reflective markings. These use larger beads or special layered systems, so the reflection still works even when submerged. It's constant evolution, because visibility at night isn't a luxury. It's survival. Think about the scale of this. Every highway, every intersection, every curved mountain road, all designed with the assumption that humans need guidance in darkness. And instead of installing millions of light bulbs, engineers chose something simpler. Use the driver's own light. Return the light. Guide the path. Next time you drive at night, notice it. Those glowing lines are silent guardians. They don't shout. They don't flash. They simply respond. You shine light at them, and they shine it back. That's smart engineering. That's physics applied quietly to everyday life. And once you see it, you'll never unsee it. If you enjoy breaking down everyday things and discovering the engineering behind them, subscribe. Because the world is full of invisible design choices, and once you start noticing them, ordinary roads become extraordinary. Thanks for watching.